I'm Lukasz. I'm very thankful for the opportunity to be here and to present. This presentation / demo will be about the Galaxy and Onedata integration. And now it has been around for some time, so probably some of you know it. But anyway, I will try to make it interesting for everyone. We should start with a short introduction to Onedata. Onedata is essentially a distributed data management platform. It's an open source project developed for the last 12 years at the Cyphernet Supercomputing Center, Krakow, Poland. The main point of Onedata is providing unified access to data that is distributed geographically and organizationally. By deploying our software in different data sites, okay, maybe I should. By deploying our software in different data sites, we build a layer on top of heterogeneous storage systems. They are integrated into a unified data namespace, but the organizations retain control over their data sets. The user may access the data using different interfaces, but whichever interface they choose, they get a coherent view over all their data. Onedata is used to facilitate collaborative data sharing that crosses organizational borders. The physical data that is located in distributed sites and on different storage systems are virtualized into logical data containers called spaces. And users of different affiliations and working groups bringing together users can access the spaces and collaborate on the data. Now we don't have much time to go into many details, so I won't, but I would like to, one important thing is that Onedata aids you for the whole data lifecycle, starting from acquisition, when it gives you a lot of options for the data ingestion and data integration, then the consolidation of the data, organizing it into data structures, replicating it, high performance compatible clients so that the data can be processed on computer infrastructures and HPC. And then what's important, metadata annotation. Every file and data set can be annotated using JSON, JSON-LD, RDF to achieve well-curated data sets through archiving, so long-term persistence of the data, preservation of the data, and then publishing and sharing facilities that with integrated PID, DOI minting, and automatic advertising using OAI PMH protocol. So now that we know a bit about Onedata, so what has been developed within this integration, which happened in the scope of the Euroscience Gateway project, ESG, and what's in it for you. So let's start with Galaxy storage, also known as object stores. This is where your histories are stored. It's subject to user quota, and now you can use Onedata as one of the storage options, which means that your files and data sets will be stored to Onedata, and then when they are needed for an execution, they will be loaded from Onedata behind the scenes. And this is bring your own storage feature that lets you configure this, and it can be used to extend your user quota. And now for repositories or remote file sources, those are external data sources for Galaxy. And also you can easily plug in your Onedata account as your repository to import or upload the data to Galaxy, and also to export your data sets, workflow invocations, and so on. And this is the bring your own data feature. Another interesting thing about this integration is how the distributed compute resources synergize with the distributed data. So on the left, we see the distributed pulsar network connected to Galaxy EU. And on the right, we see the network of data providers in EGI Data Hub, a Onedata-based ecosystem. And with that, we can achieve scheduling that is aware of data locality. So Paul already yesterday presented about the smart TPV broker that allows for more optimized scheduling. And the next step that we can do, and it's not yet implemented, but we technically have everything that's needed to do it, is to use the data locality information. So Onedata has a suitable API that can be queried to find out the live distribution of a data set, where its replicas, in what data locations its replicas reside. And then based on this information, we could make even more informed decisions on the scheduler level to optimally schedule, make it more efficient, and minimize the data movement. Okay, now for the live demo, which may be a bit hard with the mic, but let me try. And without a mouse. So you might think I'm reckless doing that, and you could be right. What can I switch to? Can I switch to the browser? Oh my god. Where's
can
the...
actually try with this one. Okay.
Okay, yeah, where's the browser?
The browser.
Yeah, I am clicking. I am clicking, but it's not
maybe
doing
it's-
anything. So
There it is. Close this
yeah, so it's the Wi-Fi is not that.
Mission success.
Thanks for being my wingman.
Because we have to share this, right?
Something happened. So yeah, so can we go here?
We'll share once again.
Can you hear me? Yeah, you probably.
Okay, if I share it, then okay, that works. You can hide. This one? Okay.
Okay, so sorry for having a stupid idea for demo, but I wanted to make it a bit more tangible for you. So instead of using screenshots, it's just to show you around. So we are looking at the Onedata interface, what you see after you log in. On the left, I get the list of my spaces, those logical containers that cover the physical data resources. And then, by the way, the sandbox space is what anybody can get access to if you want doing our getting started tutorial. So you'll be able to look into this later, but right now we are looking at the EGD demo space. And I have prepared a space that is that gets its resources from 4 data sites. We can look it up on the map. Yeah, so we have 3 data sites, and then we have the EMBL INA repository, which is remotely imported into the space. So I am actually importing by reference the data sets from the public EMBL INA repository with genomes. So they are not copied into Onedata just now. They are just referenced. When we want to read them, the request will be proxied and the data will be served. And we could look at the data distribution. This touchpad is gonna kill me, but let's try. Look at the data distribution. So maybe this one. I'm sorry. Hard with the touchpad. Okay, So what it shows us is where the replicas of the data reside. So currently this data set is referenced from this external repository, which is EMBLINA. It has not been replicated anywhere. And of course, we can run some computation on it. The data will be delivered on the fly, but we can also do pre-staging. This is something that I done here. So I said, please replicate this data here. I have replicated the data set to Krakow because I know that maybe this is a very large data set. I will be running some computation right there. So I want to have it close to my computation so that the data transfer doesn't hamper the performance and doesn't make it longer than needed. So with that, you can manage the distribution of the data. The next thing is the collaboration, the collaborative data sharing. So Onedata uses a multi-level data access control model. And at the top of that, we have the idea of space memberships and privileges. So I can say what users and groups are allowed to see this space and use it and to what extent. So I have granular privileges here saying that this specific person will be able to do that and not that on the data. And this way you can prepare big curated data sets for your working team, and then so that they can collaboratively work on it. And if you need more granular privileges, we also have ACLs, so that on the level of every file, every directory, you can say who can do what. The next thing is metadata annotation. So I don't have to stress how important it is to have well annotated data and how many advantages it has. One of the things, minor thing that you could do in Onedata, for example, so basically this data set I have just brought in a lot of genomes of different bacteria. This is just a demo data set. I'm not a bioinformatician, so I am clueless, but I have brought in some data sets of different bacteria, and I have annotated them with some basic JSON metadata. And what's important, I have here the organism name and the origin country where the specimen where it has been collected or it has been sequenced. So I can say, okay, please extract this organism name from my JSON and display it in my file browser. And like that, I have a nice overview of the different organism specimens I have here. But this is just some sugar coating. What is really important when you have thousands of millions of files is how you can navigate through them and how you can do data discovery and understand what's in your data sets. Find some specific files. And for that reason, we have the data discovery feature built around the concept of harvesters that aggregate the metadata from different files and give you a nice browser which you can query to find something. So right here, I see all the files that I have in the space, but I can say that I would like those that the organism, let's say, contains salmonella in its name, and maybe those that have been sorry for the touchpad, collected in Poland. So let's say this origin country is Poland. And then I get the nice list, which can still be very large, but you can work around it in different ways. One of the ways is Onedata gives you a REST API to pretty much everything, also including data discovery. So this is actually a equivalent REST API call that you can make to get the same results that we see on the screen. So what I've done is I have written a super simple script that just does this query and then just iterates through all the files and slams them into my catalog that I have called all Salmonella files from Poland. But instead of copying the data, I have created links to it, so to different data sets. So here I have symbolic links or hard links to the actual data sets with Salmonella. So I haven't used more quota than needed. And I have somehow organized my data in a single directory. Of course, this is just, for demonstration reasons. I'm not saying this is the right way, but this is a way you can do it. Okay, so let's move to Galaxy. So we have seen a bit of Onedata, and now how can we use Onedata with Galaxy? Because that's the point today. So here in user management, most of you probably know, but I'm stressing this because it's nice to for everybody to start using the possibility to bring your own data, so your own repositories and your own storage. So these are the two options, and you have ready-to-use templates that make it super simple to configure. You only need a couple of information to put down there. Also, you can use this preferred Galaxy storage option to say, okay, I want my data to be stored in my Onedata account. And I have done that. So let's go to the upload action and choose from repository. By the way, if we go to the second page, we can see the GTN training data. This is something that some of you might have already used. This is actually hosted on Onedata via EGI Data Hub. But on the first page, I have my Onedata account. I can see here my spaces, sandbox, and EGD demo. And when I go here, I should see my directory of Salmonella genomes, and I can do an import and run a workflow on it. And now what's quite important is to be aware and use consciously the defer dataset option. So defer dataset is such that you don't actually copy the data, you only reference it. So Galaxy will remember where it is, but will not copy it. So as not to make duplicates, which doesn't make sense. It can be residing in Onedata. And yeah, so we do this without copying. We're not gonna wait for it. I've done this before, but what we can see is I already have some history here, and I have already imported some data from Onedata, already run a workflow, and it has produced some results. So what should have happened is those results should be written to my preferred Galaxy storage, which is the which I have configured to be my Onedata account. And there you can say which directory it should be written into. So I have created this Galaxy storage directory here. And here we can see this very internal Galaxy structure of data, which we shouldn't try to understand because it's how the Galaxy stores its data sets. But what's important is that my data is now stored here. So it's not using my quota in Galaxy, it's using my quota in Onedata. If I have a nice big account here, it might be very useful. Okay, so let's go back to the presentation. Okay, you might be asking a valid question. So why should I bother? Why should I use this? There is a lot of data management possibilities in Galaxy, and this is a valid question because yeah, in some cases where you don't have elaborate data management needs, it's an overkill, and you shouldn't use that. That's the answer. But there are cases where you should consider it, and this is kind of a summary when. So if we want to integrate data from distributed data centers, join them with some remote data sets, but what's important, thank you. What's important, organize it into a working catalog that brings together different storage technologies in one namespace and can be used for teamwork. So you can give it to a group of people that will not be doing the same data management job, each one of them independently, but you can do it. You can do it in one place for everyone and achieve well-structured and curated data sets. If you need data transfers and replica management, if you are aware of you have multiple sites with data and with compute, and you want to be more aware how it's all used. If you need long-term data preservation, for example, to preserve your results, to publish them, or handle really large files or data sets. If you need metadata annotation, data discovery, or maybe you have a very elaborate data pipeline that actually uses more different systems than Galaxy, uses a couple of tools, and you would like to have one data layer that to rule them all, to serve for different software pieces, but have all the same data everywhere without nitpicking and managing it everywhere. This might be your answer. So yeah, the short summary is if you want to take your data management to the next level, you should look into it. And I'll be landing soon. This is the last slide to maybe have a peek into the future because the Euroscience Gateway project has ended. But a new one has started, so we are also together with the Freiburg team in EOS Data Commons, which I'm quite looking with excitement at the challenges ahead. We actually started some developments, or we have there is a PR to Galaxy, and there is an ongoing discussion regarding the security of HTTP headers. So if anyone is interested to chip in, just please do. And yeah, that's all. I would be very happy to talk with you if you have more questions and if you want to learn more. I'm also, please feel free to reach out by email. If you want to learn more about this and try it all out, what I've been showing you, you can simply go to the Galaxy Training Network and type in Onedata, and there is a range of tutorials for different levels and, let's say, specialties of users. But basically you get this getting started tutorial where you can create the sandbox account and play around with it, see how it works, and feel welcome to do so. And thank you.
Thanks, Lukasz. I think that was one of the flawless demos that you usually see at conferences. It's not the case usually. Any questions from audience?
Very nice thought, thank you. So when I use one of those logical folders that you show in the filtering as deferred sources for Galaxy, what would happen if you change it on the Onedata side? Like, what if you move it within the folder structure, or you like rename it or adjust the filter to the
Yeah, so this is based on file IDs that are unchangeable. So whatever you, if you move it, if you change the content of the file that has been referenced, it is still the same ID. So if you run a computation later, it will run on a new content. Because you are referencing a remote file, yeah? But so just like Google link sharing, right? If you give a link to someone and then change something in the document, they will see it when they open it. So it works the same. So of course, if you copied it to Galaxy, you get the snapshot, right? But with the deferred data set, it will be like that. If you don't want it to happen, you can use archive, for example, in Onedata that are unchangeable, and then you are sure you will always get the same.
Any more questions?
Related to this, if you materialize the data on the Galaxy side and then run tool on it in the scenario that Martin just described, whether you change it remotely, which version will the tool execute on the materialized Galaxy version or the changed remotely that one?
By materializing, you mean copying the data, or?
Yeah, I think that's both.
Well, so this is a question more to Galaxy, but I believe if you have imported something not deferred, but just copying, this copy is stored in your Galaxy storage, and this is what will be used for execution, right? So whatever was there at the moment of import will be used, regardless if you change the Onedata side of it later.
Yeah, my understanding is that even after you can still click on the data set and say materialize it now. So get
Okay.
the-
Well, that's just my lack of knowledge of Galaxy. Sorry for that. I didn't know the materialize option. But if materialize does this kind of synchronization, that it
Yeah, that's
makes
what
sure
wants.
that content is up to date, well, then yes.
I think you materialize it just once, so you can upload it as deferred.
And then you
at a certain point you
materialize
decide that you
it.
want it materialized, and then
And at
That's
this
the version.
point, at this point, it will read the data, so whatever is there at the moment of materialization will be taken, right? But as I said, you need to understand if your data is evolving in Onedata or not, and then get what you want.
Thank you, Lukasz.
Thank
I
you.
think-
Yeah.